Today we're going to be talking about graphing rational functions. Yesterday we graphed a function 1 over x, and we talked about shifts of those. There's also other types of rational functions. For example, a rational function. Okay, I say, yeah, consider the rational function where f of x is some function with a polynomial on the top of the bottom. So for example, a good example of that would be 3x minus 7 over 2x plus 1. So we're going to be graphing examples like that. We're going to also be graphing something like this, where here your exponents were the same on the top and bottom. Where your exponent on the bottom is less than the top, and where your exponent on the top is going to be less than the bottom. But what we're going to worry about on this slide is the vertical asymptote. And the vertical asymptotes happen for all values of x when the bottom equals 0. So this is when the bottom equals 0. So for our first example for this one, your asymptote would be 2x plus 1 equals 0. X is going to be negative 1/2. That'd be your asymptote. For this example, it would be when x minus 3 equals 0. So your asymptote is x equals 3. For this example, it would be when x squared minus 3 equals 0. So that's going to be when x squared equals 3, or when x is going to be equal positive or negative root 3. So that's how you find your vertical asymptote. The horizontal asymptotes are a little bit more complicated. You have to remember these rules. The rules are, when you have, a graph has at most one horizontal asymptote with the following rules. If the degree on the top is bigger than the bottom. So for example, if I have a function where the degree on the top, let's say x squared minus 7x plus 1 over x minus 2. That's what we call an oblique asymptote. What you're going to have to do is divide the top into the bottom. Okay? We're going to go through an example of that tomorrow. If the degree on the bottom or on the top is less than the bottom, so what that means is if I had 2x minus 1 over 3x squared plus 4. Well, the degree on the top is 1, the degree on the bottom is 2, so what's happening? What's getting bigger faster? A squared is going to be bigger, faster than the top, meaning the bottom is going to be bigger when x gets really, really big, or when x gets really, really small, the bottom is going to be bigger. What's 1 over a really big number? Well, that's a small number, so that's y equals 0. The degree, if the degrees are equal, so for example, when you have 3x minus 5 over 4x plus 1, the x's are getting big the same rate. So that means that your asymptote is going to be y equals 3/4, the ratio of the leading coefficients. It is imperative that you remember these rules. You need to memorize them. If you have not written them down, pause the video, write them down. I went through and explained examples, and we're going to do one of each type. So graphing that, identify the zeros, asymptotes, y-intercept of each function, and graph. So let's first talk about the asymptotes. The vertical asymptote. I abbreviate that VA. That means the bottom equals 0. The value that makes that bottom equal to 0. So x minus 1 equals 0, x equals 1. That's going to be your vertical asymptote. Your horizontal asymptote, ha. My abbreviation is ha. You look at the ratio of the coefficients. Top equaled bottom. So it's going to be the line y equals 4 over 1, or y equals 4. Zeros. There's a reason I stressed that we knew this. Same thing as x-intercepts. X-intercept, you make y equal to 0. Make your whole function equal to 0. Now, if your function equals 0, the only way for that function equals 0 is if the top equals 0. So really what you're doing here is you're setting the top equal to 0. You might want to make note of that. You set the top equal to 0. We add 12, we divide by 4, 3. So 3, so it's the point 3, 0. Your y-intercept, that's when x equals 0. So that's the easy one. 4 times 0 minus 12. 0 minus 1. That's going to be 12. So it's the point 0, 12. I paused the video because I wanted to get a double screen on there. Okay, so let's put all of these things onto our grid. So draw in your axes. Actually, since our y-intercept is so big, I might draw in the x-axis a little bit lower. I'm actually going to draw that guy in a little bit lower. Okay, so now that we have our axes drawn in, put in your vertical asymptote, and notice, vertical asymptote is a line, x equals 1. Draw in your horizontal asymptote. Notice I have it written as a line. I want it written as a line. Plot the points. 0, 12, 4, 5, 6, 7. I have that point right there. 3, 0. Since you only have 2 asymptotes, it's going to resemble the ones that we did. It's going to look like 1 over x, where basically when you have your asymptotes, in most cases they're going to be in opposite corners. So it looks like I'm going to be there, and I'm going to be there. And it's okay if you're just sketching these in. I'm okay with you guys just sketching those in. So that's what that graph would look like. Now let's look at the next one. So the next one, identify the zeros, asymptotes, and y-intercept of each function and graph. Now in this case, the vertical asymptote, I like to abbreviate it for VA, vertical asymptote. You set x squared minus 1 equal to 0. X squared equals 1. Don't forget your plus and minus. Plus and minus 1. X equals 1. X equals negative 1. Your horizontal asymptote. Ha! Look at the ratio, or look at the exponents. The top is smaller than the bottom. That means the bottom is going to get bigger faster. So it's 1 over a really big number. So that's y equals 0. Your y-intercept, you make x 0. So that's going to be negative 2 over negative 1, or 2. So 0, 2. Zeros, you make the top equal to 0. So I have the point 2, 0. On your grid, Draw in your asymptotes. Or drawing your axes. I'm sorry, I'm drawing in my axes. Then we're going to draw in our asymptotes. Since our numbers are so small, I'm going to go in units of 2 or units of 1/2. So therefore, our vertical asymptote is going to be at 1. I remember I'm going by units of 1/2. So this is going to be 5 and -5. Your horizontal asymptote, y equals 0. I know that's the axis. Still draw it in for me, please, so that I know you know where it is. Now, I have these zeros of 2, 0. Sometimes your graph will hit your horizontal asymptote when it's one polynomial over another. So keep that in mind. Sometimes they will hit it, but the end behavior, what happens as x gets really, really big and really, really small, means it's going to approach that asymptote. You have a y-intercept of 0, 2. Now, you might want to make yourself a little chart or a little number line. When x is -1, when x is 1. Well, when I was 0, I had the point of 0, 2. So what that means is that your graph is going to be all above that horizontal asymptote, approaching your 2 vertical asymptotes. So what happens? It comes down from one of the vertical asymptotes that it approached and makes a U-turn, approaches it, because I don't have any other points that hit the x-axis. So it has to turn directions there. Okay, for numbers greater than 1, what if I plugged in the number of 3? We just want to know whether we're positive or negative. So 3 minus 2, that's a positive number. And then we have 3 squared, which is 9 minus 1, a positive number. So I'm above the x-axis, but I approach that asymptote. What happens if I say I plugged in 1/2? 1.5. Let's see what happens. 1.5 minus 2, that's negative. 1.5 squared minus 1, well, no matter what, 1.5 squared is bigger than 1, so that's going to be positive. So I'm going to end up with a negative number. So I started down here negative. So I came from my negatives, I crossed my horizontal asymptote, and went positive. So I was just trying to determine where our graph was, whether it was above or below the x-axis. Now for numbers less than -1, let's plug in -2 to determine whether our graph is above or below the x-axis. So f of -2, let me make that a little bit clearer. You have, now you're just determining whether it's positive or negative. It doesn't matter. So I have negative minus a negative, that's going to be a negative. I have 4 minus 1, that's going to be positive. So therefore, a negative over a positive is a negative. So because I'm not going to cross the x-axis at all, because I have no more x-intercepts, I know that for all my values, I am below the x-axis. I come from one asymptote, I come from the end of one, and go towards the other. In general, if you have 2 asymptotes, they're gonna be going different directions. So if you end going down, in most cases you're gonna start up, come around and turn around and go back up. And then if you end up here, then you start down and you cross your x-intercept, and then you end up going towards that asymptote. There are your lesson questions for the day. Please make sure you took good notes, because these can be somewhat challenging of examples.